Hello and welcome to the second part of the tutorial on optical flow wrapping. Having a set of 3D scans of facial expressions, we are trying to convert all these scans into a nice blendable topology. This process can be split into two steps. In the first part of the tutorial, I showed you how to fit a base mesh to the neutral expression. In this second part, I'm going to show you how to fit a neutral mesh from the previous step to each facial expression scan. Let's come over here to the Gallery tab and find Alex's neutral mesh. This is the mesh we got from the first part of the tutorial. It's a result of fitting a base topology to Alex's neutral scan. Let's go back to the Gallery tab and load a target scan. I'm going to start with lips compressed expression. Let's rename the nodes accordingly. As I mentioned earlier, this step is very different from the standard wrapping that we used in the first part. Basically, you need to fit every single skin feature on the neutral mesh to exactly the same skin feature on the target scan. Otherwise, the resulting blending and thus skin sliding will be incorrect. What's important is that, unlike the previous step, this time we need to use texture information. If we were to use standard wrapping node, we would have to specify hundreds of control points manually, which is a huge amount of work, and still we wouldn't have proper blending between the points. That is why we created the new optical flow wrapping node that fits one model to another by finding similarities between their textures. Let's go ahead and create one. We plug Alex's base mesh to the left input and the scan to the right input. The models should be pre-aligned before running the computation, so let me bring them to the same position. If we select the optical flow wrapping node and go to the Editor tab, we can see a lot of cameras all around. I'll explain that in a minute. For now, let's just move the camera system higher so that its center is in the middle of the head. With this done, we can click Compute. The computation is going to take several minutes, so here and later I'll speed up the video so that we don't have to wait. As you can see, for this simple case, the fitting was done automatically. Let's take a look at the results. Note that the base mesh was fitted with almost pixel level accuracy, which you can see by switching between the models. Most of the texture holds in place, but some parts on lips and under eyes are still moving. This can be fixed, and I'll show you how later in this video. For now, let's take a look at what happens under the hood of the node, and to do that, let's load another example. Let's try mouth open expression from the gallery. In this expression, an inner part of the mouth is visible. Since the neutral mesh has a mouth socket, we need to prevent it from fitting to the interior of the mouth. To do that, I'm going to create a Select Polygons node. I also want the bottom of the neck to be excluded from fitting, so I select a polygon on the bottom of the neck and double-click on the polygon next to it holding the Shift key. Then I click Grow multiple times to select the desired area. I'm going to use predefined polygroups to select the mouth socket. Let's plug the polygon selection to the fourth input of the optical flow wrapping node. Here in the Editor tab, we can see a set of virtual cameras. The cameras observe the models from different angles. The fitting is computed only in those parts of the models that are visible by at least one camera. First, what we need to do is adjust the center of the camera system so that all the cameras can observe both models well. In the Node Parameter panel, we can go to the Camera Generator tab to create a new camera configuration. For now, let's undo the changes to the camera system and leave it by default. If we click on a camera, we'll switch it to camera mode. We can switch between the cameras by selecting their names from a drop-down list or using scrolling. Here in the camera mode, you can easily adjust the camera position if needed. Click Exit Camera Mode to return to the standard viewport. Press Ctrl and click the mouse on a camera to remove it. To increase a fitting quality for some specific parts of the model, for example here on the lips, I can zoom in and add extra cameras. Now that the cameras are set up, we can click Compute. During the processing, each camera computes an optical flow between the neutral and the target model. The optical flow provides a set of decisions on where to move each pixel. The decisions from all the cameras are then combined into an optimal solution. Here is our result comparing to the target scan. Okay, let me show you the last example. This time I'm going to use a smirk expression. Let's go ahead and run computation with all the default parameters. Here we go. As I'm switching between the models, you can see that the fitting is nice for most parts. However, of this lip corner over here, it's clearly off. We can solve that by providing a set of control points to help the algorithm. To do that, I'm going to use a Select Points node. Let's select viewpoint correspondences around the lips. For all our scans, we paint little dots on actors' faces, which can be very helpful for extreme expressions when skin stretches and changes its color so much that you can no longer find natural features on it. The points can be placed quite roughly because they will only be used as a guide. Let's connect the point selection to the third input of the optical flow wrapping node and click Compute. Now the lip corner is in place and the overall fitting looks pretty nice. Here's the final result. That concludes this part of the tutorial. So far we've been working with simple expressions which are relatively easy to fit. In the next part I'm going to show you how to process more extreme expressions. Thank you and I'll see you in the next video.